this section, we're going to talk about unit rate and scale drawings. First, let's talk about unit rate. Unit rate is where we have a ratio that compare different amounts with different units. So, for example, we might talk about 6 miles in 20 minutes. So we're comparing miles to minutes. Or 2 pounds for $3.89. So we're talking about 2 pounds for dollars, pounds for dollars. A unit rate is when the rate is expressed as one of something per some amount. So, for example, we might say 50 miles per 1 hour, or 50 miles per hour, or $1.50 per ounce, or $35 per 1 pair of shoes. So let's look at some examples. If we wanted to write anything as a unit rate, what we're going to do is take whatever it is we're looking at and write it per one. So, for example, 3 watermelons for $1.59. If we want to write that as a unit rate, we're going to try to figure out how much it would cost for 1 watermelon. So what we can do is we can set up a proportion, or we can just divide, either way. So I've already showed you the answer. Let's see a couple of ways to find it. So we know there's 3 watermelons. I'm going to put 3W for watermelons for $1.59. So that's my ratio. Now what I'm trying to figure out is how much 1 watermelon would cost. So here's my proportion. When I cross multiply to solve, I get 3x. We don't worry about the W and the dollar sign in the middle of our problem, equals $1.59. I'm going to divide both sides by 3, and when I divide both sides by 3, I find that I get x equals 0.53, which is the same as 53 cents per watermelon. Another way to approach this problem is to just know that since you are looking for 1 watermelon, you want to change that 3 to a 1, so you have to divide by 3. And since you're dividing the top of your ratio by 3, or the top of your fraction by 3, you have to also divide the bottom of your fraction by 3, which is the exact same thing we did when we solved this as a proportion. So now let's look at the next example. In the next example, we have 2 cans and balls for $5.88. I'm going to set it up the same way. In this example, we want to know how much 1 can of tennis balls is going to cost. So our original ratio is 2 cans for $5.88. And we're going to set that equal to 1 can, and we want to know how much that's going to cost. So we can cross multiply. We get 2x equals $5.88, or 5.88, and divide both sides by 2. And when we do that, we're going to find that the answer is $2.94 per can. Again, we could have just come to the ratio 2c over $5.88 and divided the top and bottom by 2 to get 1 can and $2.94. Let's try the next example. A dozen eggs for $8. So what we're trying to figure out is how much 1 egg will cost. So we know our original ratio is going to be a dozen, so that's 12 eggs for $1.08. We want to know how much 1 egg costs. So we can cross multiply 12x equals 1.08. Divide both sides by 12, or we could have just divided the top and bottom of our original ratio by 12. Either way, we're going to end up with 9 cents per egg. So x equals 0.09, or 9 cents per egg. In the next example, example number 4, we're going to set it up the exact same way. So we're going to end up with 225 miles in 25 seconds. And this time let's just divide going to figure out how many miles per second. So if we're looking for seconds in this one, or miles, we're going to figure out how many miles per second. So we want this to be a 1, so that means we're going to end up dividing the top and bottom by 25. And when you do it that way, you get the same thing as if you did a proportion, and you end up with 9 miles per second. Number 5, we have 15 pairs of earrings, and they cost $180 for all together, and each pair of earrings costs the same amount. So we want to figure out how much one pair of earrings costs. So we're looking for one pair of earrings, which means we're going to divide the top and bottom by 15. Yes. Go. And 80 divided by 15 is going to $12. So it's $12 for one pair of earrings. Now we're going to move on to scale drawings. A scale drawing is a drawing of an object in real life, but the drawing is either bigger or smaller than the object, so it can be drawn on paper. A scale is used to keep all the parts in the proportion. If the corresponding parts of the drawing are lined up with the corresponding of the real object, they proportion to one another. A common scale map, you'll see here is a map, and you can see there's a scale at the bottom that tells you that this length of this line, if you were to measure it on a ruler, is equal to 100 miles or 2 kilometers. Some examples of things. There is a blueprint of a house, and we're going to find the dimensions of the actual bathroom. So we know on this drawing that it's 3 centimeters in length, and we need to figure out how many centimeters in width. So we're going to have to do a little bit of math just to figure that out. So if we come over here, we can see that this whole length here is 6, this length here is 4, so this length from here to here must be 2 centimeters. So our bathroom is 2 centimeters by 3 centimeters. Now we have our scale written right here, so we know for every 1 centimeter that equals 4 feet. So obviously if this side is 2 centimeters, in real life that's going to be 8 feet. And if this side is 3 centimeters, in real life that's going to be 12 feet. But let's look at how we could set up the math. So we can set up the math using proportions, that 3 centimeters equals x feet and 1 centimeter equals 4 feet. So we're putting what we know in the first ratio, and we're putting the scale in the second ratio. I'm going to cross multiply and solve, and when I do that, I do indeed get that the width is 12 feet. And for the length, we know that that's 2 centimeters, and we're trying to figure out how many feet that is, and we're using the ratio to help us figure that out. So when I cross multiply and solve, I do indeed get 8 feet. Now this is a pretty easy example. Obviously I did that in my head before I actually showed you the problem. However, you need to understand how to set up scale drawing problems using proportions. So let's look at another example. This is the same scale drawing. It says if the dining room's actual width is 8 feet, so let's look at that. The dining room's actual width is 8 feet. So I would make this 8 feet. Find the dimensions of the dining room on the scale drawing and in real life. So again, we're working with our scale of 1 centimeter equals 4 feet. So the first thing we can do is figure out that the height right here, that's the same thing as the width, is 4 minus 2.5, because we know that this length is 4 and this is 2.5. So we know that not only is this 8 feet, but this is 2.5 centimeters. So if the height is 1.5 centimeters over x feet, and we're going to use the scale 1 centimeter equals 4 feet. So when you solve, you get the height equals 6 feet. Then we're going to come work with the width. We know that the width is 8 feet. I put the width in the wrong place, I'm sorry. We know that the width is 8 feet. So we know that we have the scale 1 centimeters equals 4 feet, and we want to know how many centimeters is going to equal 8 feet. Let's cross multiply and solve, and the width is 2 centimeters.